So, then I'd like to welcome everybody to this year's first Heinz Nixdorf Forum. We do this event in order to inform every researcher in our institute across all research groups about the latest ideas we are pushing forward, and all those ideas are in common strategy, for our common strategy in our institute, of course. Today's topic will be systems engineering, and thus, systems engineering must be one of our core, or is one of our core businesses in our institute when you think about the interdisciplinary design and development of mechatronic or embedded systems. And thus we have today two talks, as usual. One talk will be given by me, and the second talk will be given by Professor Rob Cloutier from the Stevens Institute. I will introduce him when he's going to give his talk a little bit more in detail. We both will talk about systems engineering. I will talk about a little bit more in a general way. I will give some overview of a survey we carried out in the last month about systems engineering, and especially about the view of system engineering in practical industry or in industrial practice. You may wonder why I'm speaking in English, and the reason is not only because Rob Cloutier is here, but I also like to welcome the class of the International Spring School on Systems Engineering, which is taking place during this week here in Paderborn and is carried out by the Heinz Nixdorf, or organized by the Heinz Nixdorf Institute, the Fraunhofer-Projektgruppe, and of course Technical University of Munich, which organized the spring school years before already. Therefore, if you have then any questions, I would appreciate if you ask those questions also in English to me, but also to Professor Rob Cloutier then. So I'm going to present, as I said, some first preliminary results of our survey about systems engineering in industrial practice. We had many reasons why we did this, or why we carried out this study or the survey. One of the biggest reasons was that we wanted to see what industry thinks about systems engineering, what they believe systems engineering is, what systems engineering is not, and what they think were the benefits of systems engineering, and also the barriers of systems engineering, of course. And the motivation for us was also very easy to see, because when we are looking at our strategy and we say at the Heinz Nixdorf Institute we want a new school for developing intelligent technical systems, or the technical systems of tomorrow, then we're also thinking about what are the systems looking like in future. And we recognize, this is not a big deal, but we recognize those systems are getting more and more complex. And there are many challenges why those systems getting more complex. I just want to introduce two challenges which I think are really easy to understand. And the first challenge is that those systems get more and more interdisciplinary. Also, different concepts based on different disciplines are possible right now. Look at the example of the hybridization of the powertrain in a car. Due to different disciplines, new concepts, new variety also exists now. And Rob and I had also talked about how many lines of code were necessary for a modern car, for a modern vehicle. It's actually several million lines of code is necessary, and we both 100 million lines, and we both believe that we flew to the moon with less than 1 million lines of code. So this is really getting more and more software in those systems, more control engineering, more electrical functions, of course. And engineers, and especially mechanical engineers, has to face that software is playing a more and more important role for the system design. Second challenge is that the development time getting shorter and shorter. Especially when you see here, for example, the Volkswagen Golf, the market time of those products, so how long the products stay on the market actually. And we see there's a significant decrease of the market time of Volkswagen Golf, for example. And this is something which is really important, so you have to be very efficient with your development, and if the systems to develop get also more complex, then you will have a problem. And we believe, and also some other people also believe, that systems engineering might be, or maybe is the only chance to handle those challenges. Of course, there are a lot of more challenges, but those were those two which I would like to mention to introduce why we started the survey. Here you can see a short outline of my talk, which I will give in the next half an hour. I will start with a short overview, how we designed this survey, how was our methodology, of course. Then I will present or point out what we believe technical systems of tomorrow will look like, what are the main functions, and then I will present the main, and also I said again, preliminary results of our survey from industry view, but also we'll have a short look how system engineering in the educational system in Germany implemented already. All right. What we can see here is the project team. We carried out the study under the supervision of the Heinz Nixdorf Institut, but all together with this Fraunhofer spin of the Fraunhofer-Projektgruppe, mechatronic systems design, and also another spin-off of the Heinz Nixdorf Institute, the Unity, which is a company from Professor Gausemeyer. These 6 persons carried out the study, and what did we do? We interviewed in total 32 companies in Germany, not only in Germany, but only in the German-speaking area. So in Germany, in Austria, and in Switzerland. And you can see there are many also very famous companies in it, almost, I would say, many automotive companies, of course, but we also had a look at the companies from aerospace. And we can see here the different industrial sectors of those companies. And it was very important for us to view at different industrial sectors, because we believe, and we will see, or I assume, and we will see later on if it's really that is, the fact that there are differences in the application of systems engineering in mechanical and plant engineering, in automotive industry, and especially in aerospace, because in systems engineering in Germany, everybody's thinking about rocket science or something like this. And we will see if it's really indeed that only aerospace people are doing systems engineering, or even we will see if automotive industry in Germany is already doing some system engineering. So first I want to start what are the technical systems of tomorrow will look like. And I will start with how those technical systems look like in the past. And we'll see that many technical systems, especially for engineers and engineers like mechanical engineers, they only focused, or the most of those systems were systems which were basically based on a strong mechanical structure, and where the development was really driven by mechanical engineers and also by mechanical problems. And this is not the case anymore right now. Right now we are in the field of mechatronics, of embedded systems. We have systems which consist of several functions and several synergies between electronical functions, mechanical functions, software functions, and especially control engineering. This is the state of the art. This is what we are developing right now. And we believe then strongly that the conceivable development of information and also communication technologies will also enable more sophisticated information processing for those systems. And we call them intelligent technical systems, or just in short, intelligent systems. Systems that can perform a more complex information processing. They can adapt their behavior to changing conditions of the environment. And there are also many buzzwords roaming around, like network systems or cyber-physical systems. But this really, a cyber-physical system is a good example of what we believe intelligent system will look like. We have physical systems with sensors, with actuators acting in a physical environment, but their information processing of each of those systems are connected by cyberspace or by internet or any other linked performance by information exactly. So this is what we believe systems will look like tomorrow, or in 5 or 10 days. But when we look, is this just a fantasy of mine? Is this just an abstract fantasy? Roman is saying, yeah, systems were getting more and more intelligent and they will be cyber-physical systems. And this is not just a fantasy, because we have good examples that such systems are already getting developed. We have this leading edge cluster, Intelligent Technical Systems, Ostwestfalen-Lippe, where such systems are already getting developed. Systems which can adopt their behavior, systems which can also gain information during operation mode in order to optimize their behavior for future situations. And there are many companies, and all those 4 companies we also interviewed in our survey, which are really right now developing such systems for the market, of course. But the survey was not only carried out with this companies from our leading edge cluster. We had, as we've seen before, a lot of more companies asked and interviewed. So one of the first questions we had to the companies was, what do you think will be the main functions of the systems of tomorrow? What will be the main functionality? And indeed, the 2 most mentioned points were that those systems have a system intelligence. They will have a more complex information processing based on artificial intelligence also. This was words said from companies, from industries. And also that those systems will be more networked together, more linked together. And this is a pretty hard challenge for the developers, because where is the system of interest? Where is the boundary of the system I want to develop? When all the system I'm maybe in charge of will be linked to other systems, and who's in charge of the development of this system. So we ask another question, also at the beginning, very abstract question or generic question to start. What do you think will be the challenges for your future product development? And we find out that the main challenge will be, or was mentioned at least, the interdisciplinarity of those systems, and also the interdisciplinarity of the development, because when we're talking about mechatronic systems design, we have mechanical engineers, we have electrical engineers, we have software engineers, control engineers. When we're talking about intelligent systems, we also have experts from artificial intelligence. We need experts from higher mathematics. So this gets more and more, this problem of interdisciplinarity gets more and more present. I would say in academia, we're talking about this 15 years ago already, but in industry, it's right now the biggest problem for them to come. And so systematic and also interdisciplinary view on the system to develop, getting more and more important. And this is what we found out in one of these easy questions, but what we already get confirmed by many companies here. And this brings me to an assumption which we like to make, which I would like to make on this point. When we're looking at our systems, they change from mechanics or mechatronics to intelligent technical systems, and when we look, what is also the first results of the survey brings us to the point that those systems get more and more complex due to interdisciplinarity, due to new systems function, and this systems complexity will increase significantly with intelligent technical systems. And when we then have a look at what is the capability of domain-specific methods, then we will see, oh, all right, they will also improve, and they will also improve in time. But the problem is here that we have a gap, and this gap between those two, between the red light and the blue light, is something discipline-specific methods cannot solve. This is a problem on a level of multidisciplinary view. So we have to use interdisciplinary methods, and this is just right now what I believe systems engineering is looking forward to solve. And when we look at the situation right now, we are here, and this gap is no problem right now. We bring successful products on the market, and this is due to systems engineering, which is used to overcome this gap, to challenge this gap. But I believe that in future, this gap will significantly be bigger, and I also believe that systems engineering methods must be improved. Maybe not in a sophisticated way like the academia might see it, but I think they have to be improved to be used in industrial practice, so really be applied in industries. And this is, as far as I can say already now, is really a big challenge for systems engineering right now, or a big point to do. So let's have a look at the results of the survey in more detail. And before that, we wanted, the first question we wanted to ask the companies is, just right now, what do you think is systems engineering? And we will come to this question. But first, we did our homework. We made, of course, our research work, and this picture here. This picture shows the history of systems engineering. I don't want to go so far way back into the ancient time. Let me start here with the Bell Laboratories, which are formerly or mostly known that they made the first systems engineering approach in communication technologies. And also in Germany, in this time, or the 2 decades after that first systems engineering approaches in Bell Laboratories, there was also a systems engineering community in Germany. In Germany, the word for this was Systemtechnik. In the 1970s, for example, was the German Day of Engineering, which has the topic of systems engineering. So from VDI. This is very interesting, but because when we look at systems engineering in the 80s and the 90s in Germany, there is no systems engineering. The term is not used for publications in academia. It's not used by the companies. This is very interesting because in this time, mechatronics started. Mechatronics became the big deal. Those changement from mechanic system to mechatronic system took place, and we call it the mechatronization of those products. And mechatronics, as I said before, is there you have different disciplines working together, and why is no systems engineering then more apparent for everybody? And we find this aspect just paradoxical, because systems engineering community and mechatronics community, or as a discipline, and systems engineering, as you can see, is not a new discipline. It's maybe last days or last years it becomes more apparent that it's already existed years before. But both disciplines were a little bit isolated from each other, at least in Germany. And I found it also very interesting, because I studied mechatronics, and from mechatronics I came to systems engineering, and I will go back to mechatronics because I want to develop mechatronic systems. So I think both disciplines are very close and very related to each other, and I think it's just very significant that there was no relation in the last years in Germany. And so this we couldn't use to say, what is systems engineering? Then we looked at this picture. And this picture shows the systems engineering standards, and we asked ourselves, is this systems engineering? And when you look, there are so many standards, and all of the standards, maybe some standards are focusing one part of systems engineering. Some of them try to focus on complete systems engineering, some of them just a part, and very much of them, they are very connected to each other. And I think it's clear to see that it's no wonder that someone gets confused, especially when you have to apply systems engineering when you see this picture. And we just think there was an uncontrolled growth of some systems engineering standards, and it might be better when we only have one standard, but this is of course a difficult topic. But as we can see, it's also looking at the standards didn't help us to find out what systems engineering is. So finally we came to the idea to ask the companies, what do you think, what is systems engineering is? And here we have the results of the mentioned answers by the 32 companies we asked, and almost every company said one of the biggest deal is, or one of the biggest topic of systems engineering is a holistic system thinking, whatever this is. But this was mentioned from almost every company. And when you look at all the other topics, they will come then after this. Yeah, you can see here's a pretty mixture of a lot of things, which I would say, yeah, that's a part of systems engineering. This is a very important aspect, but you cannot say there's a common sense of what systems engineering is in industry, or what they believe systems engineering is, and also not a common acceptance of the meaning of systems engineering. And one problem is that, and this is what all the companies already said, that systems engineering, the term itself, seems to be too generic for most of them. It seems like everybody is free to interpret what systems engineering is for him and or for her, and this might be one of the biggest problems right now. We also have already some talks the last 2 days that systems engineering is the term for itself is a little bit problematic, but maybe you can say something about this later on. But when everybody feels free to say what systems engineering is, we also feel free to make a first proposal to say what was systems engineering in our survey at least. One basic proposal, we call it a concept of systems engineering. This is also not very new. It's not that we invented this view, but because we just made this picture in order to talk together and to interview those companies and to see what they believe systems engineering is and what the benefits are. And we think there are 3 important parts. The first part, and this is what many people think is systems engineering, is when you have from a technical point of view, you just look at the system you want to develop. You make models. I don't want to go into this topic of modeling, but at least you have to define your requirements, you have to define your architecture, you do some analysis, you make some simulations, you make at least tests, and then you make an optimization of your product. But this is only the point of view when you're looking at the system from a technical point of view, from what the real engineers are maybe doing, or the engineers. There's another very important side, and this is the project in which the system is getting developed. And there are other things in interest. There's an interest what are my resources which I can use? What are the stakeholders which are involved? What are the main activities which have to be carried out? What are the risks, the time, and also the costs? And we believe that, well, I would say, this here is product engineering, this here is project management, and systems engineering has to consider both views in a very integrative way. And every system engineering method has in mind that it also has to make an effort here for the system design and also for the project in which the system, and I pronounce system design, not systems design, in which the system is getting developed. And we did, with this small definition of our concept, we challenged the companies and say, what do you think is the benefit when systems engineering is understood in this way? And here's also, again, the results when we asked them. And the main answer was, and I can totally emphasize this point, is that systems engineering allows the company or the people who's working there to orchestrate all the different disciplines which are involved in developing the system. And there are many different disciplines, not only the technical disciplines, but also the project management and all the other views. And even though we have to think about the consumer or the user, this is what is really important in this way. But also the improved planning of a development and other points are very important. And another thing, and I think this is also not very new, but it was something the companies really emphasizes during our survey, is that systems engineering, or the higher the complexity of a system is, the greater the benefit, at least they believe, the greater the benefit of systems engineering might be. And this is also sometimes an excuse why not to use systems engineering, because they believe their systems are not so complex, because they're developing those systems almost 50 years long or very long, and they are really fit in the systems, but they forget they also need some suppliers maybe one day and new people who starting to engineer those systems. So this was something we argued about also, but what we discussed, and I just present the results from the companies, of course. So what was the next question? The next question was, when we now know a little bit more what systems engineering is, or how systems engineering is seen in the companies, we asked, what are the obstacles for an efficient systems engineering, or for systems engineering at least? And one interesting point was that almost every company said, for us it's a problem to make an analysis if systems engineering is really worthy in cost, in money. It's a really monetary analysis about systems engineering. They say it's not possible. I'm not sure if it's really not possible, because at the end of a life cycle of system, you should be able to analyze what were the costs and what the improvement. But of course, it's really difficult. And this might be, or is one excuse why many say systems engineering, it's not what we explicitly maybe do, because we have no resources for systems engineering, because there's no proof of effort that it's really worthy. So another point was that particularly in small and medium enterprises, we found out that there are when at least one or two, or at least maybe just a few people who have really knowledge about systems engineering and systems engineering methods. In larger companies, there are more people. There are many people. We ask experts. I have to pronounce that one. We really ask experts that were familiar with systems engineering, and we asked them, and we saw that maybe there are many people who are familiar with systems engineering, but in most companies, in Germany at least, there is no such systems engineering department or systems engineering or company-wide systems engineering acceptance in those companies which we asked. And this might be a little bit different in the States, I think so. And even in large companies, and which we really asked, was not implemented systems engineering with a specific department or specific persons who only did systems engineering. I'm also not sure if it's really necessary, by the way. So when we asked this first round of questions, which were very generic questions, we tried in the second step, or in the second part of the interview, to go a little bit more into details on systems engineering, and therefore we had to define what are the core topics of systems engineering. We used different definitions which already exist. Of course, the definition of NCOSI, and defined 7 so-called, we call it, core topics of systems engineering. There were requirements engineering, domain-spanning system architecting, integrative production, system development, model-based or model-driven engineering, visual or early verification and validation, and product lifecycle assessment, and process tailoring. And for each of this topic, we have had several questions, and we asked how is the importance for your company, for example, for model-based engineering, for model-driven engineering. And we also asked the companies, and they were really honest with their answer. How fit is your company? How capable is your company in doing this this part of systems engineering? And due to the lack of time, I will only explain three: only requirements engineering, domain spanning system architecture, and virtual verification and validation. A little bit more in detail, but also very briefly. And so you can see here some results. So try to sum them up. Requirements management might be the field of systems engineering which get the highest attention in companies. It's still very challenging, and it's still very important because the requirements, or the number of requirements, is still increasing, and also the connections between requirements is increasing a lot. But many companies, they spend a very high effort in requirements management. And when we look at large companies, they also have dedicated tools to manage their requirements. When we look at the more small and medium companies, we realize they have some tools for requirements definition like Excel or Word, but you can hardly make complete requirements management with those tools. But this is not the capability of small and medium enterprise in Germany right now. So we think there is a high intention on this topic. And many companies, and this is really what I realized in this survey, they think requirements management is systems engineering. They say, okay, we make some requirements management and systems engineering is done, but it's definitely not the case. It's not the same. It's just a part of it. Let me come to the next core topic of systems engineering, which we examine in our survey, and this is the domain spanning system architecture. I chose this one because in this field, many companies are not very fit right now. Indeed, when we looked at many companies, there is nothing like a real system architect in some companies. It's the companies which we asked, of course. I'm not speaking about software engineering. Software engineering is a completely different field. There is everything implemented. They are using architectures, they're using those methods, but I'm speaking about the complete engineering technical product here. And also some companies are doing this. At least, but when we see what they are doing, they are not making models of the system architecture. They're making maybe some drawings, maybe some paintings. There is no common database of all the information which are necessary and which are domain-spanning information to use them later on in the development process. There's maybe a short view at the beginning of the development or a specific point, and then the view or the paper because of more drawings, they just get forgotten. This is the fact here. And we believe there's also a little bit more effort, also from the academic and research, but I think this can only be done together with the industry to implement those, this point of view to make a domain-spanning architecture of a system to develop. And even though maybe some expertise is missing, and not only at the companies, I'm speaking also expertise at the students we are educating, but we come to this field a little bit later, how the education system engineering is going on in Germany. And some companies, they all just have the one wish, they want a tool which can manage all this. And this tool is not available right now. Maybe not in the complete vision with a PDM and PLM where you put all the information of an architecture into your vision. But model-based systems engineering actually is a research field, is exactly what many companies I think will need and would be very efficient in this case. So the last core topic I want to introduce is the early or virtual verification validation. And to me, as for mechatronic systems design, of course, virtual models and virtual prototypes is our core business. And I would say in academic, it's often state of the art. But in many companies which we ask, especially small and medium companies in mechanical and plant engineering, they really consist of making physical prototypes first. So when you make a physical prototype, you don't do a virtual prototype then because you have to know a little bit more information, and you are starting directly with the experimental phase. Large companies, especially here in aerospace, which we asked, of course, they make a lot of virtual models, and they are very fit also in hardware-in-the-loop tests and so on. But especially small, medium enterprises, they still believe that it's more safer and you get more information. And maybe this is one point, but it's not the easiest way and not the most efficient way to do always a physical prototype first. Of course, in this case. So here we can see in the portfolio all those core topics evaluated with those two fields, like how important the company think those core topics were and how the current state of the company is. And we see that every field is here in the area of a critical success factors for the companies tomorrow or the future. And this picture doesn't say so much. It says, or at least that all those core topics are of high importance. But what was more interesting is when we look at the different industrial sectors which we interviewed, and then we will see there is a significant difference between those industrial sectors. And first I would like to look at the aerospace sector, because when we look at there, we see those bubbles are more on the right side. So those companies are a little bit more fitter. I would say systems engineering is established by those companies. They use in systems engineering. Of course, they also have challenges, and they also told us which are the challenges of them, but they are way not so, but they're way wider than the challenges other companies will have, I think, in the next years. And there's more about continuous tool support for those companies is one of the biggest challenges. But they are doing a lot of those core topics, and they also really fit in many of those topics. And at least all the principles are really confirmed and really embedded in those companies. When we look at the automotive sector, and this is really interesting, because the automotive sector, it's not that far on the right side like the aerospace sector, but it's moving in this way. And this is clear because we ask a lot of OEMs, and OEMs promote a lot of systems engineering in the last 2 years, and there will be a lot of more systems engineering come from the OEM reviews because they have those problems. They have to manage to orchestrate their development together with a lot of suppliers. They have to make a common view of the system to develop. And they are doing, right now, they are doing a lot of effort, and this is in Germany, a lot of effort in systems engineering and introducing new methods also for this. And then, at least, we look at the mechanical and plant engineering, which is very strongly in this region also, but it's in Germany a lot of more small and medium enterprises. And the importance there is also very important, all those core topics of systems engineering. But systems engineering at all is really unknown, or at least nobody is doing it. There's no one in charge for systems engineering. They are developing right now very successful. I can't say nothing about that. But when we are right with our vision that systems getting more complex and more interdisciplinary, I think they might get a little bit problem because they are not prepared for systems engineering in this case. And at least I can say one of the biggest problems still, or many companies, and I said that already, they just think right now it's not worthy to do some more effort in the early design phases and more effort in the application of systems engineering methods. This is the meaning of right now. So at the end, I also want to make a short view on the situation in education in Germany. And first, we ask also all those companies, what do you believe? What systems engineering needs to do? What is his expertise? And we find out that there's three different skill profiles, at least, or three different things were mentioned, but all those things, I think, in systems engineering have to get together. First, you need a good systems engineer always has a field of application. He needs one field of application where he can apply his methods, whether in automotive industry, in oil industry, in aerospace. Over the time, good systems engineer, of course, can change a company and also the field of application, get more application fields. But at least many companies said you have to be fit, have very depth knowledge in one field of application. Otherwise, the second profile is, and this is also what a systems engineer needs to do. He needs a very wide span of knowledge. He has to understand all the problems of the different stakeholders. He has to understand the problems of the customer, the problems of the other engineers, the problems of the other developers, and also other companies which we work together. And this is very difficult because on the one side you have really expertise on one field, but you also need understanding for a lot of more problems around your field of expertise. And this is really challenging for people, of course. And this is very challenging on systems engineering. And the last point, which was really mentioned very often, I was surprised that it was mentioned so often because I really also can emphasize this point. At least we have, I would say, around about 20 systems engineers here in research. it's well-trained soft skills are of very high importance. Those systems engineering has to intervene between different disciplines, as I said. They have to intervene between different departments, different persons, different views in company, maybe also between different companies. So you have to be very well trained in soft skills and also management skills, because this is I would say one of the major success factors to implement systems engineer by a person or by a company. So what are the study courses in Germany about systems engineering? We found 32 in educational institutions in Germany, with every one of them is offering a master program in systems engineering, and some of them also a master degree program. We also had a look at the curriculum. What are they really teaching in those study courses? And then we found out there are basically two groups of study courses. One group was implemented by computer science, so it's more like an expanded software engineering course, and the other study courses were more implemented by engineering science, so it's a little bit engineering with a little bit software engineering often. And we believe that this is not very good. We have to make sure that those disciplines getting, even in education, more and more together. We have to integrate those interdisciplinary views already in education. Otherwise, we cannot handle them in practice or in industries when we don't teach the people or the students to realize that many problems will be solved on a very interdisciplinary level. So at the end, I just want to sum the major points up, which I already mentioned. And first, I hope I could make you understand that the technical systems of tomorrow, we believe, are intelligent technical systems which are due, or which have a really high complexity due to them increasing interdisciplinarity, of course. We have found out that there's a common view between industry and academia. It's not a big difference between how the industry sees systems engineering, at least in Germany, and the academia view. Both believe that systems engineering is one of the major disciplines to face the challenges to develop intelligent or technical systems of tomorrow. But we also think that there must be more effort to improve those methods. Maybe not to make it more sophisticated from academic point of view, but it's only really successful systems engineering is only successful when we also implement this in the industry, in the practice. And therefore all the research done, and this is what I really realized this in this case with the survey, where I was also confirmed, we can only do research in systems engineering with a close interaction between industry and academia. Otherwise, no systems engineering method can be solved by a dissertation when it's only implemented at least together with the company in the real application case, of course. So, and as I already said, the systems engineering study courses which we have in Germany right now are not sufficient, or maybe we should think about also doing in Paderborn more systems engineering in education, because I think we do a lot of lectures which are in the field of systems engineering, but we are not bringing them closely together, especially also in computer science and engineering. And when we look at what I said at the beginning, when we look at our major objective for our strategy as Heinz Nixdorf Institute, and we say we want a new school for the development of technical systems of tomorrow. These are some major points we have to look at. We have to look at developing more systems engineering methods. We have to bring computer science and engineering science, which I think we are really good in it already, more together. And we have also to look at the education and bring more efficient education courses educational courses for systems engineering, and also in Paderborn, because I think in Paderborn, or this institute, we can be real proud of what we are doing already in systems engineering. But it's also a big chance, because many companies will come to this point to need systems engineering, and this is what the survey already said. I said preliminary results, we have not evaluated everything, because systems engineering will be one of the major topics for the industry in the next 5 years. So I would like to thank you for your attention. Since Professor Gausemeyer and Professor Trechtler couldn't be here today, I'm also chairing this event, so if you have any question to my talk, you are free to ask this right now, or remarks. And this is, I have to say something, I forgot at the beginning, this was the first presentation of these results. We were making those results in the last days. I have to, forming it together and evaluating some of those interviews, because I really wanted to present it in this way, in this forum, because it's an internal, we have a lot of guests today, but it's an internal discussion, this topic of systems engineering here. So feel free also to make remarks and to make improvements. Rob, please.
I find it interesting that the companies said they don't see the value of systems engineering. And yet, all of those things that you asked them about, they rated as very critical. So it does show that, at least here in Germany, there is still a disconnect of the value of system engineering and yet what system engineering does. And they haven't connected those dots yet to understand that those things that they value are what makes up a large body of knowledge of systems engineering.
That's one of the biggest conclusions we also saw in my presentation, because I'm not pretty sure if everything we are talking about in Germany must be under the field of systems engineering. I think we do a lot of those topics, but it's more implicit systems engineering in Germany.
Yes, absolutely.
And this is maybe one of the biggest reasons why we did this survey. Okay, if there are no any other questions.
Can you remark something on such a system, like in my country, for example, a lot of engineers, they go to different companies and they work, and after a couple of years, they go to some management post like MBA or so.
Could you please repeat it? I speak a little bit louder, because I
was just asking that in my country, a lot of my friends who are engineers like me, they just go to different companies and work for 2 or 3
we call it dual education, where we have a student which is also at a company and also at the university. We have many of such programs, because this gets you very good expertise in this application field, of course. But I think this is maybe one of the important points here. And what we do in research, and all of our PhD students, many of them work in close cooperation with industry projects, and this is really important. Otherwise, you cannot come to, as I said, to new methods which can be really implemented. So this is really one of the biggest deals, to do it closely together with companies and industry and academia. So if there are not any other remarks or questions, then I will thank you again. And I would like to introduce the second speaker, Professor Rob Cloutier. I told you already, we are glad to have him today here. Professor Rob Cloutier is in the School of Systems and Enterprises at Stevens Institute of Technology in Hoboken in New Jersey. He has more than 20 years experience in systems engineering in different companies, Boeing, Lockheed Martin, you said already. I think 7 years you've been there. So we are really proud to have you here. I'm glad to have you here and give us some overview of your systems engineering experience. And his research interest is especially model-based systems engineering, system architecting, and also systems engineering patterns for the architecture. And this is the main topic of your talk. And I'm also very interested, because I'm also big in pattern for systems engineering, and I'm